Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss algebraic approaches to evaluate limits. Let's go ahead and do an example. We have the limit as x approaches 1 of x squared plus 6x minus 7, all divided by x minus 1. Solution. So the first thing you should do whenever you're evaluating a limit is take the number you see here, in this case 1, and plug it in. If you do that, you'll notice that you get 1 minus 1 on the bottom, and so you end up dividing by 0, so that doesn't work. So we have to do something else. In this case, that something else is going to be factor. So we have a limit, and it's always really important to write down the limit sign until you actually plug in the number. So the numerator should factor. Let's try. I'm going to go ahead and put the parentheses, and then x here, and then x here. And on the bottom, we still have the x minus 1. Okay, we need two numbers that multiply to negative 7, but add to 6. So I think plus 7 and minus 1 should work. Let's just double check that. So if we do x times x, we get x squared. That's okay. And then negative 7 is going to come from 7 times negative 1, so that's okay. And for this middle term, the 6x, we basically use the inner and the outer. So the inner is 7x, and the outer is negative x. When you add this inner piece and this outer piece, you're always going to get the middle term, which is 6x, and so it certainly checks. So all is good there with the factoring. Even better, the x minus 1 cancels, so this is now going to be equal to the limit. And again, notice I'm writing the limit sign again, very important, as x approaches 1, and then we're left with parentheses x plus 7. Again, I can't emphasize that enough. It's a very common mistake for people to forget to write the limit sign. So now, this is where you drop the limit sign. When you take this number and you plug it in for the x, that's when you don't write the limit sign. You get 1 plus 7, and so you get 8. And that would be it. So the algebra isn't hard, but again, the notation is important because it's a limit. You always want to write limit until you evaluate the limit. What does that mean? Well, in this case, that means evaluating it. In other words, taking the 1 and plugging it into your function here. You drop the limit sign, you add the numbers, and you get 8 as the answer. Let's go ahead and do another example. In this example, we have the limit as x approaches negative 2 of 1/2 plus 1 over x all over 2 plus x. This one looks a lot harder, and it can be, but we're going to try to do it in a very, hopefully, easy way. So let's try. So I'm going to start by writing down the problem again. We have the limit as x approaches negative 2. And then in the numerator, we have this sum of fractions. So we have 1/2 plus 1 over x. And in the denominator, we have just 2 plus x. There's a couple ways of doing this problem. You could just basically add the fractions and go from there, and it would work, but it takes a lot of steps. So there's a trick. You can basically eliminate the fractions right at the beginning. So to get rid of the 1/2, you need to basically multiply by 2. To get rid of the 1 over x, you have to multiply by x. So if you multiply by 2x, you should be able to get rid of both of them. So if I put a 2x here up top, that would do it. However, you're not allowed to do that in mathematics. You can't just multiply by 2x. But you can multiply by 1. So what we do is we divide by 2x. We're essentially multiplying this by 1. And keep in mind there is an implied parentheses here, and there is an implied parentheses here. Now we're going to distribute this 2x. So this is going to be equal to the limit as x approaches negative 2. So let's see, we're going to take the 2x and we're going to multiply it by 1/2. What that's going to do is it's going to give us 1/2 times 2x, and basically the 2's will cancel and we'll just get x. It's going to be x, and then we're going to take the 2x and multiply by 1 over x. What's going to happen there is we're going to get 2x times 1 over x, and the x's will cancel and we'll just get 2. So we're just going to get plus 2. Over on the bottom, we still have 2 plus x, and we still have the 2x. And then now you see x plus 2 cancels with 2 plus x. They're exactly the same. This is equal to the limit as x approaches negative 2. We're left with a 1 up top, so it's 1 over 2x. And now we've finally reached the point where we can plug in the negative 2. Notice at the beginning of the problem that wouldn't have worked, right? Because you would just get 0. So Now we drop the limit sign, so we get 1 over 2 times negative 2, which is negative 1/4. So boom, really nice. This is probably the easiest way to do the problem. Again, the other way to do it would be to actually add the fractions and go from there. So very, very clever technique, very powerful technique that you can apply to other problems that look like this. So if you have a problem that kind of looks like this, you can apply this technique and hopefully work it out and get the correct answer. Let's go ahead and do one more example so you can get better at limits. Okay, this is our last example. We have the limit as h approaches 0 of 4 plus h, and it's all being squared, minus 16, and all of that is divided by h. As always, when you see a limit like this, you should always take this number and try to plug it in, and you'll notice that we get 0 on the bottom, so that doesn't work. So there's a couple ways to do this problem. The way we're going to do it is, I think maybe the easiest way is we're basically just going to multiply out the numerator here. So we have the limit. Remember to always write the limit sign until you plug in the number. And then let's multiply this out. The formula for this is a plus b quantity squared. If you think of a as your first term and b as your second, you square the first, so you get a squared. You multiply the a and the b and you double them, so you get 2ab. And then you square the last, so you get b squared. Super powerful formula, worth memorizing. So here you square the first, so you get 16. Multiply them and double them, so 4h times 2, right, because it's 4h, and then times 2 is 8h. And then square the last, that gives you h squared. And then you have this minus 16 here. All divided by h. And look at this, the 16s cancel. This is the limit as h approaches 0. And then we have this 8h plus h squared over h. As an alternative to this formula, you could FOIL, but I really don't recommend it. I remember resisting learning this formula, and then when I learned it, it's like magical. It's just so useful. So this is the limit as h approaches 0. We can pull out an h now. When we do that, let's see, what do we multiply by h in order to get 8h? Well, 8. And what do we multiply by h in order to get h squared? Well, h. So h times 8 is 8h. h times h is h squared. It's really easy to say h and 8 incorrectly here because they both sound the same. So this is the limit as h approaches 0. And we're left with parentheses 8 plus h. And so now this is where we drop the limit sign. You take the number and you plug it in. So pretty. 8 plus 0 equal to 8. What a beautiful problem. Really nice. And that would be the answer. Fun little limit here. Hopefully you've learned some mathematics in this video. If you feel you have, make sure to check out more videos on Chegg. Until next time, good luck and take care.